Let's look at some angle relationships in circles. We've already talked about central angles being the same as their intercepted arc, and the different types of inscribed angles, which are half the measure of their arcs. But let's look at some other angle relationships. We have here that if a tangent and a secant, or a chord, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So since ray BC is a tangent and ray AB is a secant, they intersect on the circle. Therefore, angle ABC is half of the measure of arc AB. So what that means is if arc AB is 100 degrees, then the measure of the angle would be 50 degrees. You may write this theorem and draw the picture if need be on your note card. Let's take a look at some examples. We're going to find the measure of angle EFH. EFH is this angle right here. It is made up of a tangent that intersects a secant. So therefore we know that if this arc is 150 degrees, that angle is going to be half of that arc. So the measure of angle EFH is simply 75 degrees. Now if we want to find the measure of arc GF, which is, let me get another color here. We want the measure of this arc right here. Well, if you notice, it is made up of angle FG and let's say M. So if we know the measure of this angle here, then we can find the measure of the arc. Well, in order to find this angle, we notice we have a linear pair. Together, these two angles are 180. So we need to do 180 minus 135 and get 45 degrees. So this angle here is 45 degrees. So the measure of arc GF is going to be 2 times that angle, so it is 90 degrees. So again, your highlighters and matte pencils are going to be your friends here, so you can highlight the picture. This one I want you to do for class. Draw the picture on your paper, highlight the arc that it's asking for, the angle that it's asking for, and find the angle relationship to help you find the missing measure. Remember, this is due in class. Another theorem that you may write on your note card along with a picture is that if two secants or two chords intersect in the interior of a circle, the interior is the key here, then the measure of, say, angle 1 is going to be half the sum of arc AB and CD. So if I know that arc AB is 100 degrees and arc CD is 50 degrees, then that means that the measure of angle 1 would be half 100 plus 50. So if the two chords or two secants intersect inside of a circle, we add the arcs, divide by 2, and that gives us their angle. Notice they go in a line, starting with this arc to this angle to this arc. We do have vertical angles here. We also have linear pairs, so you still have to remember all of your vocabulary throughout the year. This example here, I want to find the measure of angle AEB. Well, if you notice, this angle AEB opens up to arc AB. Well, if we go across, we also know arc CD. So all we have to do to find the measure of angle AEB is take 1/2 times 113 plus 139, or the sum of the arcs. In this case, we have 1/2 times 252, and we get that the angle is going to be 126 degrees. So now I want you to look at this one and find the measure of angle ABE. Notice angle ABE is this angle here. We do not know its intercepted arc or the one across from it, but you can find this angle here and use that angle relationship. Remember, this one is due in class. Another theorem that we have is that if you have a tangent and a secant, two tangents, or two secants that intersect in the exterior of the circle, then the measure of the angle formed is half the difference of the measures of its intercepted arcs. So now, since the angle is outside of the circle, we're going to subtract the big one minus the small arc, divide by 2 in order to find the angle. These may be on your note card as well. Let's look at an example. So here we're trying to find this exterior angle. We know the two arcs, so all we have to do to find x is 1/2 times 87 minus 7. So x is going to equal half of 80. So here we get x is 40. If we take a look at this one over here, we're given the angle, but we need to find the missing arc. So we know that the angle is equal to half of the big arc minus the measure of arc BD, or x in this case. So remember, if we have a fraction, we want to multiply both sides by the denominator, and we get 148 equals 200 minus the measure of arc BD. Now when we subtract our 200, it's okay if you get a negative, because we have negative 52 equals a negative measure of arc BD, which we can't have, so we can divide by -1 and everything turns positive. So here we get that x would equal 52. Take a look at this picture here. Again, you can copy the figure down, but use your matte pencils or highlighters in order to find the measure of angle FKH, which is this angle down here. This one will be due in class. This chart here sums up all three of the theorems that we talked about in this video. If the vertex is on the circle, it's half the measure of its intercepted arc. This one is an inscribed angle. This one here is a tangent that intersects a secant. But no matter what, if the vertex is on the circle, the measure of the angle is half of its intercepted arc. If the vertex of the angle is inside the circle, we add the two arcs and take half to find the angle. But if the vertex is outside the circle, that's where we take the two arcs and subtract them and take half of them to get the measure of the angle. Don't forget about your central angles. So we could also add one down here that if the vertex is on the center, we know that the measure of the angle is equal to the intercepted arc. So these are all the different types of angles you could have in a circle and the relationships they have here. Remembering this one is an inscribed angle. This one down here is a central angle. This is all information you may have on your note card. Because now you're going to start having pictures that are more involved than the ones we've been looking at. For instance, here we want to find the measure of arc YZ. This is the arc we want to find. Well, if you notice, we have this angle here, but we don't know this arc. We do know this angle, but we don't know either one of these arcs. But we do know this arc here, and we can find this angle by doing step 1, 180 minus 113, which gives us a measure of 67 degrees. So this angle right here is 67 degrees. which can help us find this next piece, which would be arc VY. We can find the measure of arc VY because we know that the angle 67 degrees is equal to half the sum of 68 plus the measure of arc UY. So again, we have that fraction, so we multiply both sides by the denominator. Oh, that's a U and that's a Y. And we get that the measure of arc UY is 66 degrees. So now we know that this is 66 degrees. Now we can use the other one where another theorem where the angle, the vertex of the angle is outside the circle. So now we can take the two arcs, subtract them, divide by 2 to find the angle. Oh, white won't work, will it? So this third step here is we know that that 49 degrees is equal to half the difference of the measure of arc YZ minus the 66 degrees. There's our fraction, so divide by the denominator. Add 66 to both sides. And we get that the measure of arc YZ is 164 degrees. So what you need to start doing is having those matte pencils and highlighters, finding something that you can find and looking at it step by step. In this case, it took us 3 steps to get to the final answer. But this is where the different colors will come into play. It'll help you really organize your thoughts. So now you're going to have your chance. I want you to find the measure of arc LP, which is this arc right here, using the given information. Copy this figure down and see how many steps it'll take in order to find the measure of arc LP. It will be due in class. Good luck!